right, in mass scale. Suppose I can able to do this in 25,000 rupees. I am paying 150 bucks for a coconut tree, per coconut tree. I am ready to pay him 200 bucks because 50 rupees for Vadamala garland I am anyway doing it. Okay, right? Now I am doing it for 200 rupees. I can basically get this done with say 100 trees or 200 trees he makes the cost. The government can give subsidy also. There are hazardous job which we can basically replace. Okay, but then every machine that is operated also needs a human who will claim, who will bring it and claim. Robo cannot walk from some place, and so he has to fit it, he has to operate it, but then his job becomes less hazardous. This is an example I just imagine could be one where the skill set is changed. He knows he is now basically trying to climb a coconut tree, make a robo climb a coconut tree. His now skill set is not climbing the coconut tree, but to make a machine climb a coconut tree and operate it, right? So when we look at domains, we have things like early detection of breast cancer. Today mammogram cannot do it. Doctor can justify on that. Can a mammogram find early detection? No, right? But temperature variations, now we can say that early temperature variations happen at least 6 months before the cancer sets in. This is now a conjecture. I don't know whether it can be proved. Diabetic retinopathy, cataract. There is Chronix.ai, Chironics.ai, which basically has mass screening of cataract, which is very, very important because cataract beyond some stage can become very detrimental to retina. Doctor can justify my statement, right? So early detection of cataract is something. In the case of education, I just talked about this personalized learning environment. On the environment side, we can talk about predicting air pollution, which is done now, right? Actually, Brazil has a very nice case study of prediction. China has one very nice case study. Agriculture, crop and cattle health. New Zealand, interestingly, has a very, very nice case study on cattle health. Differently abled, there's a lip reading which is done by Cambridge, lip languages, which can, so I can basically, for a hearing impaired or a speech impaired, I can just talk to the mobile, and by my lip reading it can translate it to text and show you. So these are all very interesting applications that have been developed, right? So these are some things which are extremely important from an AI perspective. These are very interesting examples, working examples, like that is some language, I don't know what is it, but it's access to cities. If you focus your mobile camera, that will automatically translate and tell you this. That is basically you get something very close to a close. You go to a place, you take a photograph, then Google comes and tells you what is that place, what is the importance of that place. That's what you see. This is an ambitious Google Glass thing where you just see a person, you don't know, but Google will tell you who is that person and you go and handshake with him. So these are some ambitious projects that have brought up. But all these things needs a lot of communication infrastructure, a lot of computation that needs to happen. And the computation cannot happen on your devices. Like if I want to put the entire translator on your device, will it be possible? How much memory it will take, how much power it will take, these are all questions. So whether it should be in a cloud, it should be, so there are a lot of technical issues. Once you have such a type of applications defined, there are a lot of technical issues that need to come up. But these are all manifestations of AI. And this is very important for a customer relation. You could go to a completely unknown place and he says, this welcome, and so I don't eat onion and garlic, so he just gives me a food without onion and garlic. I'll be extremely happy to do that, right? So these are very interesting examples. So AI systems, initially it is not something new, right? 20 years before, my washing machine will rotate for 15 minutes if I have put half. If I put full, it will rotate for 60 minutes, right? It was intelligent in that way, right? It took the weight of it and then it decided on how much it should weigh. So, so the initial AI systems were rule based. There was no data available. on the current context, it just sees if this is what is available, make this decision and do it. If this is what is not available, do this, right? So it was all completely rule based. There was no previous history nor past nor future, but it just took the current context and this. An interesting example is this washing machine. But then came machine learning, where you basically train with patterns and then you tell them that if this is the pattern you see, this is the answer. And then you go and deploy it, and wherever it sees this pattern, it gives you this answer, right? But what is deep learning? It does machine learning, but also when it makes mistakes, right, while deployment, it automatically learns the mistakes when pointed out, right? And so the main issue is deep learning. Today, the entire machine learning and deep learning has come up very big today because I have a facility to collect data, store data, process data, and give answers fast. This type of an infrastructure did not exist, say, 10 years before, and that's why AI and machine learning did not come, right? My basic raw capability of handling data is the game changer here. And then there were architectural things like graphics processing unit, the GPUs. You might have heard these words, and if you're not in the CS or electrical profession, but it's quite common in the CS profession. So you have this, GPUs and type of architecture which can quickly process a lot of data. And today, a mobile phone can store close to 100 gigabytes. It's very common today, right? So with this type of infrastructure, building machine learning and deep learning have, so that's the thing. So AI is nothing new. AI has existed in the past, it's currently existing, it will exist in future, but the way AI systems have developed from rule based to machine learning to deep learning is basically because of the availability of the compute and the storage infrastructure, right? Right. So with this, I believe that AI will do a lot of good. AI will also have some disruption. That disruption would be beneficial to many, or beneficial to some, not beneficial to some. I don't want to even say many, or I don't want to quantify because we don't know how to quantify. We cannot live without AI. Rather than making it as a necessary evil, we'll try to look at AI to solve problems and start getting into solving problems effectively. That will automatically boost our economy. And if organizations like TIE can take a concerted effort to find out who will have negative impact on AI, or any sort of negative, not just humans, job loss, but any other negative impact of AI, including loss of data privacy, etc. So many legal angles are there. And if we could come out with remedial solutions for those, because this is going to happen, and when that thing happens, if we are prepared for it with some remedial solutions, right, within your own organization, we'll not talk about the entire country. You are running a manufacturing mechanical factory. If you want to compete, if you want to give quality products, today we are working at micrometer accuracy, or it will go down to nanometer accuracy. There are mechanical components which can manufacture up to nanometer accuracy. You have to do lot of sheet based analysis of bumps or irregularities. Lot of things today has to be automated, and there should be an interpretation from an AI engine which says that this type of bump is okay, this is not okay. So if you just look at manufacturing today, there are a lot of interventions, and there needs a quick delivery also, because today the market requirements are high. Now if you look at all these things, you cannot run away from automation, you have to come to automation. But by that automation, if you can identify a list of individuals who will be negatively impacted, and you find a remedy for it, that's a good thing. And that's the way we can progress on this. Okay? And this is my take on AI. Thank you very much for this opportunity. you.